moly. At any rate, the Johnny Depp one was a piece of crap, no matter what anyone says. You want to know something funny about the kid that played Charlie in the first one, the good one? Never acted again. It's the only thing he ever did. Just didn't like it. He's a vet now in New York. Weird, hey? That's a pretty big movie. Never acted again. Huh? Maybe he was so traumatized by the Orange Oompa Loompas.
Maybe he was racist.
Yeah, maybe he was. Huh? Yeah, true that. But I bet he doesn't work with any of those black dogs or anything like that. That'd be horrible. What?
Compared to the first movie, only the ear was actually edible.
Huh?
The rest of it wasn't. The ear was for the gummy bear prop. Only the ear was edible.
In which? What are you talking about?
In the middle of the Chocolate Factory movie, only the ear was edible in gummy bears.
Oh, okay.
And they actually tried to get Chocolate River, but it just kept going bad. So they had to do it over and over again.
Movie trivia aside for the day. Let us move on and fill in a bit of this and then because obviously I'm an idiot because I didn't tell you guys to do this, so we're a little bit behind already on the second day from where I wanted to be, but that's okay because you guys are rock stars and we're going to have no problem catching up. Again, though you can hear, I'm not feeling particularly well again. I'm powering through because I can rest over the weekend. That's the plan. I went to bed yesterday at 4 o'clock. Tried to stay asleep right through, but I couldn't. I had to get up at 8:45, watched one episode of Star Trek Discovery. If you're not watching Star Trek Discovery, you should. It's really, really good. And then I went to bed after that. All right. So answer me that question. How might you actually measure the distance from the school office to this room? Yo. All right, you could get the blueprints of the school to actually measure it? Or would the blueprints of the school allow you to find a measurement? Which is it? It would allow you to find a measurement. It would not allow you to actually measure it, would it? No. No. Listen to me. What's the difference between actually measuring something and finding the measurement? What's the difference? Corey, I see your hand, man. Stay cool. What's the difference? When you find it, the measurement is already there. Okay. Okay. So if I asked you to measure my height, what would you do? Sure you do. There's a million things around this place to measure with. What would you do to measure my height? Somebody help my brother out here. What would you do to measure someone's height? Actually measure it. What? Tape measure? Okay, and then what? Come on, all of you have the wall in your house where your mom and dad were measuring you growing up. What do you do? Okay, Corey.
You just put a book right on top of where you were, and then you measure from there to the floor.
Absolutely. That's actually measuring, right? Could you find my height any other way? Corey.
If you gave us some hints about some other measurements, like how long your shirt is, we can find your total height.
You can actually do what we're going to do today and find height. So there's two different ways to do it, right? You're absolutely right. You'll find the distance from here to the school using the blueprints. But have you ever actually measured it? No. So I'll ask again. How could you actually measure that distance? Ash.
In steps.
Okay, what's wrong with that? Because I'm not saying...
It's not the same for everyone.
Yeah, it's not exact, right? It's imperial, isn't it? Right? My steps are going to be different than your steps. And I'm going to make you pay taxes on my steps because my steps are smaller than yours. Excellent. Good. Corey.
Are we going to... The minimum distance between or the distance it takes to actually get to the office?
That's another interesting question. What's the distance from here to the office? Is it down the hall, down the stairs, and around the rotunda? Or is it a straight line from here to the office?
Or is it to the rotunda and a straight and something down through the whole.
Same thing. Which is it? You don't know, do you? For us, as regular people, not Superman, what do I mean by the distance from here to the office? Walking. Or riding, whatever. But down the hall, down the stairs, around the rotunda, into the office. That's the distance I mean. If we had the blueprints for the school, could we find the straight line distance? We couldn't? Could we draw a straight line from here to the office if we had the blueprints? Yeah, but you could draw that straight line right through the floors, couldn't you? It's only a drawing. So I could, right? But I could also use it to find the distance that we would have to travel, correct? Good. Corey, what?
You just take a string and just tie it to the doorknob of this room.
Yep.
And then take it all the way to the office and tie it to the doorknob there and measure the string.
Yep. That would work. Any other way? Pardon? You could lay them, flip, 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 flip. Absolutely. It would be super fun to make you guys do that, but I won't.
Could we actually do that though?
No. Nobody has said the last one. It usually only 1 or 2 kids in the class get it, and they never call it the right thing. You know that thing that you walk along, goes click, click, click?
Yeah. Oh,
Nobody knows what it's called.
the meter wheel?
No. It's called a trundle wheel. It's called a trundle wheel. I got one right there. It's under my hockey stuff, which is clean, so you don't have to say, ew, grody. It has that thing. It's got a wheel and a clicker, and every time you go a meter, it goes click, 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 and then you can count how many clicks it does. That would work too. Now, we've already done this. Lots of different tools to measure things. You guys just did it. You said meter 6. You said tape measure. You said trundle wheel. That's 3 of the 4 right there. The point I'm trying to make is there's a lot of ways to do the same job, right? You're not locked into anything. But what do we generally use? If I say we're going to measure something, what do we generally use? What were you going to say, Dana? A ruler or a tape measure, right? If we can read rulers and tape measures, we're in good shape for measuring stuff, yeah? All right, so turn the page over. There's a tape measure. Some of you already know how to read those, some of you don't. It says right here that they are split into sixteenths. Why are they split into sixteenths? What a stupid number. Is there anything smaller than an inch? No. And we got to break it down. And why can't we use decimals?
Because it's imperial and stupid.
It's imperial and it's dumb, so they use fractions. Right? So, if this whole distance is 1 inch, what's that? To the first big line. That's a half. Well done. But it's also 8/16, right? Okay. What is this to the next big line? A quarter, which is also what? 4/16, right?
I think the screen might be laggy a bit.
It probably is. And what's this last little one? Oh, it's really lag. I've already done a purple line.
Abracadabra.
It's Leviosa, not Leviosa. Hey! What's that purple one? 1/8, which is 2/16. And then each little tick is a 16th. Everybody understand? Great. Tell me those 5 distances. Read the tape measure. Ethan. The first one is 1/4. Always good to get the first one out of the way, Ethan, because it's always the easiest one. Now I wouldn't ever call on you for the next 5. Slick. It's like you've been in my class before. Christian.
For the second one,
11/16. Abso-smurfly correct. Christian, well done. Next one. Now they're starting to get more difficult. Now the hands aren't going up as fast. What's the next one? Oh, Ethan, you're badass. What is it? 1 3/8. Somebody stop him. Christian, fourth one. 2 13/16. Look at this guy. And the last one, Corey. I'm surprised, Corey. It took a while for you to get your hand up there.
Actually, I have my hand up for the first one.
Oh, I just missed it. Okay.
3 7/16.
Absolutely correct. Can everybody see how that works? Believe it or not, I have many friends that work in the construction industry, which is a very good summer job to have. They'll pay you $20 an hour to pretty much do nothing except work hard. You don't have to think. And what all my friends say, because they find out I'm a math teacher, why the hell can't people read a tape measure? They get mad at me for it. It's my fault that they can't hire somebody that can read a tape measure. So if any of you go out and get a job this summer, working on a construction site, and you can read a tape measure, you make damn sure you tell your boss that you learned in math class. Deal? Because I'm getting tired of being blamed that nobody can read a tape measure anymore, even though I don't teach more than 100 kids a year. But apparently the fact no one can read a tape measure is my fault. All of you can read a tape measure, right? We're good? Okay, prove it. Go. Half of that's metric, half of it's imperial. But there's a trick. I messed with your heads somewhere. See if you can figure it out. Don't say it out loud, Ethan White. Just fix it. The top of that's metric, the bottom of it's imperial. So what are you allowed to use on the top half that you can't use on the bottom half? Decimals. Why?
Because metric can use decimals and imperial can't.
Because metric's the smart one. Oh, perfect. Delicioso. What's the first one? Just say it, buddy.
11.4 centimeters.
11.4. Well done. What's the second one? Tricky. It's a hard one. 13. Somebody whispered it over there. What's the third one? 16.7. Yay. 16.7, 13, 11.4 what? Centimeters. Yay. All right, now, what did I do on the bottom to mess with your heads? Ethan, now you say it. This one is 4 5/8. I didn't split this one into 16ths, did I? No. So you got to keep it in eighths. You got to check the tool you're measuring with. What's this one? 5 1/2. What's this one? 6 7/8. And what's this one? 7 1/4, because it's 1 2/8. Can everybody read a tape measure? So when I give you your first quiz in 2 classes and there's a tape measure on it, you're all going to get those questions right? And then I can take a picture of all your tests and carry it around to my idiot buddies who say no one can read a tape measure and say these 30 kids can. Right? Okay. You already did this, right? I signed that one a couple of days ago. The fraction one.
Still too laggy.
Yeah, it's still too laggy. Then we're on the second fraction one that's all multiplying. Seamus. Bonus points for good punnage. You know what? Some of my friends and I, we decided we were going to write an opera about punning. but we got lazy and we ended up with a play on words. The 5 people that are laughing are all getting A's. The 5 people that are smirking are getting B's. The 5 people that are like, you're a dink, are getting C pluses. You get it, right, Allie? It's always good to have a Corey in the audience who laughs at everything. Everybody likes to do that. When I was 21, 22, 23, I was in a play. And my friends came to see the play. And the audience had about 300 people in it. And I made my friends split up. So I would have somebody nice in every section of the theater so they could start the laughing at the right times. It didn't take much to get people laughing because the whole play, I was in my underwear. So, see, you're already laughing and you didn't even know anything about the play. It's a funny play. This one, when you do all the work, you're left, you cross out all the letters except for I and W. 800-pound monster, 400-pound monster, IW. Groan. I have another one for you because I'm in a jokey mood. Also because I'm filled with cold medicine. You guys all know the joke about why 6 is scared of 7, right?
Yeah.
Everyone knows that joke. Because 7, 8, 9, yeah?
Yeah.
But why did 7 eat 9? Nope. Why was 7 so horrible that he ate 9? Because you're supposed to eat 3 square a day. Get it? 3 square meals. 3 square is 9. Oh yeah. Math jokes. Yeah. You want a science joke just while I'm in the mood? One electron says to the other, or no. One atom says to the other atom, hey, I think I lost an electron. The other atom says, are you positive? Stop it. I'll be appearing here till the end of June.
Yeah, right.
When do science teachers tell jokes? Periodically. Damn. Nice one. Okay. All right. Okay. Did you hear what happened when oxygen and magnesium started dating? It was like, OMG. Okay, I'm done. I'm really done. Hey, shut up. It doesn't make it very funny if you do it that way. It's like MGO. Lame. Because magnesium oxide is a thing. But not oxygen magnesiumide. No. All right. Excellent. Move on. Today's stuff. Okay. So if everybody has the book, you should be on page 17 now. Right? Right? Okay. Today I'm going to give you a booklet that has all the stuff from Math 10 that you're ever going to need. All the formulas, everything. But for today's work, the only part of that booklet you need is right here, and it's in your book. Okay? So we're going to use this. Now, what we're going to work on today is something that is useful in every course, every time you ever have to deal with numbers. Whether you have to deal with changing money to another country, whether you have to deal if you're getting a good deal on kitty litter when you're buying it at Walmart in a giant box, whether the bacon that you buy at Save-On is as good a price as the bacon that you buy at Safeway. What I'm about to show you is very, very powerful. It is also what is used to do things like figure out how fast a car is going after it's crashed from pictures. Things like that. What we're about to do here is very easy. It requires you to multiply one thing, and yet it gives you that much power over numbers in the real world. So we're going to talk about that first, then I'm going to show you how to use it, then we're going to actually use it, and then we're going to solve some problems with it. Okay? But we'll start with the actual thing that is happening. It's called proportional reasoning. And basically it means this. You don't have to write this down.
Well, you can't see it.
It's not working? Son of a bee. It'll work in a minute. I'm going to do this. I'm going to do this. I'm going to do this. Huh? Yeah. Screw you. And then I'm going to do this. Yeah. And then I'm going to do this. And then I'm going to do this. And then everything's going to be working.
If you turn it on.
It's on. Don't be that way. Oh, it's off. It was on.
There it is.
We'll see. You know what always works? Pens and a whiteboard. They never crash. They work forever.
Well, the pen's die.
Yeah, but only an idiot would only have one pen. I got like 700. Some of them are even cool colors. But that's not sexy to write on a whiteboard. That's old school. So nobody wants anyone doing that. But when you got wireless and video and tablets, then it's sexy. This sucks. Go away. You're such garbage. I want quality.
That's on.
Oh, yeah, well, it's on, but it's not visible to you guys. Now it should be. Kinda. In a minute. Ta-da! Magic. Right here, I have two fractions, yes? Okay? Now, you guys already know this. You call it by a different name, but you know that if I take y and I multiply it by a, I get ay, yes? And if I take x and I multiply it by b, I'm going to get xb, correct? Yeah, I know it's lagging, but that's correct, right? And you also know, hopefully from grade 9, because your teacher did some similar triangle work with you in grade 9, that those are equal. This is called proportional reasoning. This is what we're going to use to convert measurements both within imperial system and within the metric system and between the metric and the imperial system. Everybody cool? So, basically what it says is if you start with any fraction and you make it equal another fraction, you can cross the multiplying and you're going to get them to be the same number. Everybody good with that? So here's what you do. In this blank spot right here, this is how it works for measurement. You take your measurement. This is the thing you want to convert. Now, in reality, every single number is technically over 1, right? So if I say I have 7 gonectigazoinks, it's really 7 over 1 gonectigazoinks, isn't it? Everybody cool? All right, so you take the measurement that you have, and then you multiply it by the following fraction. The value that you want over the value that you have. And you make this fraction, and then you do this. And you can convert any value to another value. You're going to do it in chemistry. You're going to do it in physics. You're going to do it in biology. You're going to do it in economics. You're going to do it in accounting. You're going to do it when you're shopping. You're going to use this all the time. You're going to use it when you're changing money to go to another country. You're going to do it all the time. So let's use it first here. We're going to use it on this really easy one because you don't need the fraction. You guys already know that centimeters to meters, you just have to move the decimal twice, right? You already know that this answer is going to be 4.85. You already know that. But I'm going to show you how it works with the fraction, so when we get to ones that you don't automatically know, you'll see how it's done. Everybody with me? So we start with the value, the measurement that we are converting, which is what? 485. Technically, it's 485 over 1, isn't it? Okay? And then we multiply by the fraction. What value do I want? I want meters. What value do I have? Centimeters. Then I need some numbers here. Where do I get the numbers? From the chart. 1 meter, 100 centimeters. Which number goes with the M? 1. Which number goes with the cm? 100. 1, 100. And now it's just two fractions multiplying, right? 485 times 1 is 485. 1 times 100 is 100. 485 divided by 100 is 4.85. Does everyone see how it works? It's super easy. That's all you got to do. We're going to do 1, 2, 3 together, then you guys are going to do 4, 5, and 6. How do we set up number 2? Whatever, it's gone. How do we set up number 2? I've got 57 inches, right? And what am I going to multiply it by? I need feet, and it's over inches. What numbers go in the spots? What goes with what? 1 foot, 12 inches. 57 times 1 is 57 over 12. Now you will notice a bunch of numbers are disappearing. That's again the high qualityness of my machine.
I think you should fix it if you stop recording.
No, it doesn't. It does it when I'm not recording as well. It's just garbage, Louis. I've updated, I've done everything I'm supposed to do, and it still does it. The computer I had last year never did it, ever. But that wasn't as sexy as a Surface, so I had to get a new one. Because this is way sexier. So, when you see that, what do? Divide. What happens when you do that division? Somebody gets out their calculator, and what do they get? 4.75. Is that okay? Why not? Imperial doesn't use decimals. But 0.75 is 3/4, isn't it? So it's 4 3/4 feet. Or 4 feet and how many inches? 9 inches. Because 9 is 9/12 of a foot, which is 3/4. Is everybody cool? That's the hardest conversion you can do today. If you get that, you're good. If you can understand how we got from 4.75 to 4 feet 9 inches, you're awesome. If not, just wait a minute. You'll get it in the long run. Okay, I said we were going to do 3 of them together, then I was going to get you to do 3 by yourself. So, set up number 3. What do I start with? 15 yards. Times, what do I want? Feet. Over yards. What numbers go in there? 3 feet, 1 yard. So it's 15 times 3, 45 feet. Now, already you guys should have seen something here. When the 1 was in the numerator position, what math did we do? 485 over 100. What math did we do? What math is that? Division. When the 1 was in the numerator position, what math did we do? Division. When the 1 is in the denominator position, what math did we do? Multiplication. There's a quick shortcut for you, right? If you can remember in your head where that 1's going to be, you don't even need to set up the fraction. Nope, I'm good. So you guys should do number 4, 5, and 6 by yourself, to the best of your ability. Set them up. Tell me what the answers are. Don't yell it out loud. Take a moment and make sure, because there might be a trick or two. One little tick, remember, is feet. If you don't have your calculator, that's no big deal. Just write out the fraction that you would have used. Or if you're too lazy to punch into your calculator, you're going to wait till I put up the answers. That's fine too. But make sure you write out what you would have done. Oops, screwed that one up. There. Number 4 is a good example for me to talk to you guys about assessment. When you work out number 4, you end up with 136 over 3, yes? Right? And you do that with your calculator, and what do you get for an answer? 45.333 repeating, correct? Is that allowed?
No.
Why? Because it's imperial. Now, if you stop right there on that scale of 1, 2, 3, 4, what do you think I give you? That's the right answer. So what do I give you? Does that show me you understand how to make a conversion? So what do I give you? But it's not on a 1 out of 1 scale. It's on a 4-point scale. That's worth a 3? I agree. How would you get the 4? How would you finish it? That's 45 and 1/3 of a yard, right? Right? Because 0.33 is 1/3, yeah? Does that get you a 4 yet? No. Because what does yards break down into? Feet. 45 yards, 1 foot. Does everybody see what happened there? Okay, now Ash, I would argue that that's kind of like a 2.5. This would get you a 3, and that would get you a 4. Does everybody understand? Because as we go further and further into the year, I'm going to be assessing your open-ended work on that type of scale. Does everybody understand? You'll still pass if you just do it. But if you show me that you get what's going on, you get the higher grades. Is everybody with me? Now, sometimes I can't do that, right? If the question is just right or wrong, it's impossible to do that. But if there's a chance for you to get to an answer and go further, I'm going to be applying this scale to it. Is everybody with me? Okay. So what's the next one? going to be 2016 divided by 12. What is it? 168 feet. Exactly, right? There's no decimal. What's this one? Seamus. 22,192. Now, 90, what? What is it? 92. Thank you. Now, what's weird about that number right there? Miles are imperial, right? Should we really use 4.2 miles? But do they? Yeah, they do. Like a marathon is 26.2 miles. Even though we're not supposed to use decimals with imperial. Sometimes people do in the real world. So the point I'm trying to make, I see both your hands. Let me finish my thought because I'm full of cold medicine, and if I don't, I'll screw it up. The point I'm trying to make is, even though this is not in a form we're used to seeing imperial measurements, the math that we do with it is still the same. Okay? Oh, your calculation was wrong. All right, well, what is it really? 22,176. Okay, Kristen, what were you going to ask? You're going to sort that out? Hey, man, sometimes fingers get in the way, right? One time I told my friend to meet me outside in a sex. I was texting the person. I wanted to say in a sec, and it came out as in a sex. She said, no, thank you. Probably a good thing. All right. 4 more easy ones, except for number 10. Please notice that we're going to do 10 questions where we just do the calculation. We do no other thinking about it. Then we start moving into wordier problems. Set those 4 up, write them down. And if you want, after we've done number 10, for 11 through the end, you're allowed to sit with friends because there's discussion that might need to happen. So Bailey, you'll be able to move back with Allie. Well, you don't have to, but Kingston's probably going to move over with Ethan and Carl, which means there'll be an empty desk there, and then Allie will be all by herself. But then if you go back there, then Manjo will be all by herself. Huh? Huh? Oh, I thought you said Allie's pretty needy, and I was going to be like, ooh, that's not very nice. Double thumbs up. I got to make sure I know names. Hey, who sits there? Right, Serena. Ayla, Manjo, Bailey, Carmen, Emma, Aisha, Corey, Harkirat, Louie, Liam, Seamus, Ash, Justin, Chandler, Connor, Lena, Dana, Harnoy, Raul, Christian, Gabe, Allie, Kingston, Tyler, Ethan, Carl, Shamir. Good stuff. Good stuff. Now I'm going to work on learning your middle names. I'm just kidding. I'm not going to learn your middle names. Unless you have one of those cool names that you need when the middle name sounds better. Or if I'm really mad at you, like when your mom's really mad at you and they yell all your names. I don't know if your moms do that, but mine did. That's why I gave my kids 2 middle names. So I had 2 levels of anger. Bethany. That's only one little bit of anger. Bethany Brianna. That's quite a bit of anger. Bethany Brianna Isabel Myers. You're dead. My son's initials turned out problematic, though. He's SXC Myers. Sexy Myers. But we didn't think about it. What are you going to do? And by now, you guys should be pretty sharp with these until you get to number 10, because number 10 is a bit of a hassle. Who has an answer for number 7 for me? 1,000.
Inches.
Now, obviously, that's a math class question, isn't it? Because would you ever measure something that far away in inches?
No.
That would be like saying I live 3.4 million centimeters from the school. It's idiotic, isn't it? You would never do that. I live 34 kilometers from the school. But it's a math class, so we got to throw in those questions because I need to prove to you guys that it works regardless. This one, 125. This one, 37. 3,725. Now, what's the problem with 10? Seamus? Kilometers all the way to millimeters. Is that on your chart anywhere? No. You got to go millimeters to centimeters, centimeters to meters, meters to kilometers, right? Or, what if you remember all the prefixes? How many of them are there? Does anyone remember? 7. It goes from kilo down to milli, right? Yeah. So when I'm going kilo down to milli means the decimal place is going to have to move 7 spaces, right? So I have 17.2 millimeters. And I'm going up to kilometers. So is the number going to get bigger or smaller? Smaller. And it's got to move how many spaces? 7. Kilo down to hecto. Anyone know the next one? Deca. Then what? Then base. Then deci, centi, and milli. So 1, 2, 3, 4, 5, 6. And what goes in the empty spots? Zeros. So you can do it that quickly, or you can go piece by piece. Everybody with me? If you were going piece by piece, you would just do this 3 times. You'd go to centimeters to meters and to kilometers. Is everybody cool? All right. Everybody take a moment, shake your brain out, move if you wish to sit with someone to discuss these. The first couple of questions are very easy. They're barely more than we've already done. But then it starts getting a little more difficult. Hey, look, there's that 485. It showed up at the end here. It just disappeared and came out down there. Quality.
Magic.
That's one word for it. Okay, so I'm going to assume that everybody has done the brain shaking they need to do and is comfortable where they are. Okay, let's go on. Oh, so you are moving. Okay.
I just need to stretch my legs.
Stretch your legs. I understand 80 minutes is a long time to sit in one space. I don't like it any more than you guys do, and I have a comfy chair. What's it smell like? Coconuts? Flowers? Allie, what's her hair smell like? I'm a boy, so my hair smells like soap. If you guys have been alive in the 70s, you would have seen crazy stuff they were putting in shampoo back then. Eggs, beer, and the commercials would say it, right? Our shampoo fortified with beer. Apparently it's very good for your hair, I don't know. Or at least it was in the 70s. I don't know if it is now. Yeah. I don't know, dude. Because it's filled with protein and hair is dead protein? I don't know. I don't make shampoo. But really, when you read the ingredients of your shampoo, you will wonder why any of that stuff is in it. Because it's crazy. It's things like potassium stearate. I don't even know what that is. Because if you've seen Fight Club, you know that all soap is rendered fat. So all of you should have no problem doing 11 and 12. 13 has a teachable moment in it, which I would like to discuss with you. So do 11 and 12 right now. Was everyone able to get 11?
Yeah.
Everyone got 11? I only had to change the feet because that was already in inches and I had to remember to add it in at the end. Everything cool? Okay. There's two things you can do with 12. What is one option? Liam. Sorry, Seamus. You can go everything to feet because you know that's 15 feet, right? And change it all. So you know you have 17 feet times 12 to inches. You could do that. Or you could go 5 yards times 36 plus 2 feet times 12. But they're both going to give you the same answer, which is what? 204. Now, when we get to 13, we need to talk. Because 13 is the...
Sort of, maybe.
Which one? 13? 13 has a problem in it. You know we're doing a measurement unit, so we know we care about the measurements, yeah? So what are the numbers that I have to deal with here? I got 6 yards and I got 5 inches. So what math do I have to do? I got to divide 6 yards into inches. But I can't divide inches and yards, can I? So what do I have to do to the 6 yards, Chandler? Convert it to what?
Yards.
It's already yards. I got to convert it to inches. So I take my 6 yards and I want to convert it to inches, which is 36 over 1, right? So that's 216 inches. Now what do I got to do? What? You're going to divide it by 5, right? And what are you going to get for an answer? What do you get? 43.2. If you leave it like that, what do I give you? 2.5 or 3? Because what's the actual answer? How many banners can I make? I can only make 43 of them. Now here's what I wanted to talk about. What if the banners instead are 7 inches? So I still have 216, but now I'm dividing by what? 7. What's my answer? 30.85, right? How many banners can I make? 30. Why don't I round that up? You were always taught to round up. Yes, exactly. I can only make 30 whole banners. Does everybody understand that? It's another example of when what we would do in math class doesn't work in real life. Everybody get it? Okay. Is everybody cool with 11, 12, and 13?
How did you get 17 feet?
I just did that one in my head because I know 1 yard is 3 feet. So I just did 5 times 3. Some people were saying they were going to do that anyway. So I wanted to say it's perfectly okay. If you have a memorized one, go ahead and do it. Or you can do it the long way. What are the two ways I could do number 14? What's one of them? I could go kilometers to meters. So I could go 2,000 minus 755. What else could I do? Convert the meters to kilometers. 2 minus 0.755. And they will both give me the same answer, except this one, 1,245 meters, and this one, 1.245 kilometers. Is either one better than the other? Either? Do I care which one you do? Corey, what?
I'd say that the one in meters would be better because there's no decimal places to worry about.
If you want to do it that way, you can. That's the point I'm trying to make. Both of those show me you know what you're doing. What's different about 15? I have to answer in kilometers. So 2 of those have to change. Which 2? Meters and centimeters. So I keep the 1.35. What does this guy become? Some of you should already be seeing it. Meters to kilometers is a 3 decimal place, right? So what's it going to be? 0.125. And centimeters to meters. Ooh, how many decimal places is that? If you don't remember, what do you got to do? You got to convert twice, don't you? Meters, centimeters to meters, meters to kilometers. And what do you get?
Very small number.
It is a very small number. But what is it? It's good practice. 40 centimeters. To go to meters first, it's 1 over 100. So it's going to be 0.4, yes? It'll show up in a second. And then 0.4 over 1,000. So I need to move the decimal 3 more places. What goes in the spots? Zeros. So I need 3 zeros, then a 4. So I come down here, 3 zeros, then a 4. Then you can add that in your head. And it's 1.479. Now, why would you ever, yes? Oh, 0.174. My 5 and 4 didn't line up very well. 5, 4. When do you think you would ever need to be that exact? Yeah. Anytime you do surveying, you see those people out there with the laser thing looking at the other person way far away? You ever see that when they're doing construction? This is what they're doing. They're doing grade 10 math with the telescope. And they're being paid crap loads of money to do it. Can you guys do conversions? By the time we finish our second unit, you'll know all the math you need to do that job. But you'll all still be asking me, when am I ever going to use this in real life? $16. What do you got to do? Myers has to go to yards. Get out of here. 4 miles has to go to yards, and 13 inches has to go to yards. Now something weird's going to happen here. What happened? How many yards are in a mile from your chart?
1,760.
So I got to multiply that, and what do I get? 7,000.
40.
and 40, right? Now I've already got 12 yards here, so how many yards do I have before I get to the inches? Right? Everybody agree? Now how do I get from 7,052 yards and 13 inches, which gets me 2.5, how do I get from that to the 4? Talk to your neighbor, talk to the person across from you, see if you can figure it out. What would you do with that 13 inches? Because right now, 7,052 yards, 13 inches. I'm happy, but I could be a lot happier. What would you do? Give everybody else a chance, Corey.
That's why I raised my hand like that.
I know. I appreciate you raising your hand. What do we know about inches? What do we know about inches? It's the smallest measurement. And it leads into what? What's it lead into, Louis?
A fraction.
13. Gabe? 13 inches is not 1 yard, it's 1 foot. So I have 7,052 yards, 1 foot, and 1 inch. Does everybody understand? If you show me this, I'm happy. This happy. If you show me this, 7,052 and 13 over 36, I'm this happy. It'll show up. If you show me this, I'm this happy. I'm so happy, my smile is up to my eye, and I'm beaming. It just depends on what level of happy face you want to get your teacher to. That happy gets you through. That happy gets you through with a B. That happy gets you through with an A. But are all of them the right answer?
Yes.
Yes. Is everybody with me? Sweet. Stay with your partner because you guys are going to screw up 17 and 18. Go. If you're confused, what should you do? Right. So what confused you?
Oh.
Okay. So you're cool to hear, right? Okay. Well, 13 inches. We want it as simple as possible, right? Well, we know that 13 inches, we know 12 inches equals 1 foot, correct? So 752 yards and 1 foot covers 12 of those inches. But I needed to cover 13 inches. So there's the 12 inches and there's the 13. Understand? Get it? Okay. Just like I'm 5 foot 8 inches tall. Well, in inches, I'm 68 inches tall. Because the 5 feet is 60 inches. And then there's 8 more to get up to the top of my head. 68. Got it? People say I can't explain stuff. It's hurtful. It is a big picture.
I did both of them by myself and it was easy. Right.
It's me! Because of course you would all want a 3 by 5 foot painting of me in your house. What? Oh, I didn't give myself an iris. Are we at a point we can discuss? You think you're finished? You think you did it right? How much you want to bet? Doesn't have to be about money.
192 inches.
You concur? So, I want to know how many inches the frame is, yes? Right? So what do I got to do with 5 feet? Times by what? 12. What do I got to do with 3? Which gets me 96, because 60 and 36, right? But then I got to do that twice. Except, I'm going to draw a green frame around my picture. Everyone agree? And then there'll be a frame down here, yeah? That is 36 inches long. Agree? What's happening right there? It's not long enough. That's not how frames work, is it? A frame that falls apart. So when you do number 17, that's the real life version, right? This one, I only got to buy 192 inches. Go to the frame store. I need 192 inches of frame, please. You go home, you start putting your frame on, what happens? It's not enough. You end up looking like a tool. So what do you got to do? You got to remember that the frame goes out further than the picture, doesn't it? So if this part is 60, how long frame do I need? I need 60 to cover the picture. I need 62, don't I, Connor? And what do I need up and down? 38. So how much frame do I actually need to buy? 200 inches. Did you get it right, Seamus? Everybody picking up what I'm putting down? Which part, Ayla? Okay. Are you cool with how we turned the 3 foot by 5 foot to inches? Okay. So you know that's 60 and you know that's 36, right? And you know that that means that part and that part is 96 inches, correct? 60 and 36, right? And then we had to do it again. 96 there. And when you add it, you get 192. You cool to there? Okay. But that won't work, will it? Because if my frame stops at the edge of the picture, both up and down, then there's going to be a gap in the frame, isn't there? So I have to buy more frame. The picture is still 60, but I had to go further out here to cover the edge, and further out here to cover the edge. And I told you the frame was 1 inch thick. So I didn't go 60, I had to go 60 plus that one and that one to get 62. You with me? And then I had to go up and down. There was 36, but I had to buy the up part because frames look like that, don't they? Right? So I needed that 36 plus that one and that 36 plus that one, making this 38. So I really needed 38 there and 62 there. And 38 and 62 is 100. And then I needed it again down there to get 200. You cool? Now again, was the math difficult? All we did was times 12 and add, right? When did we learn to multiply and add? Right. But applying it, you really have to think about it, don't you? And that's the big difference between what you guys have been doing in math up till now and what math is going to be like this year. Does everybody understand? All of you can do all the math that you need. But now you're going to have to use the math that you know to do more math. Everybody cool? Up till grade 9, we would teach you something and that'd be it. You're like, yay, you're brilliant. And then we'd walk away from it. And now, this year, we're going to say, hey, remember that thing you learned in grade 5? You're using it now. But your grade 5 teacher didn't say, hey, you're going to need this later. Everybody cool? All right. Number 19, came off a provincial exam. It is a horrible question. If somebody can tell me why it's a bad question, I will give them a gummy bear. Forget doing the math. Tell me what's wrong with that question. Seamus. You might, what's that mean? Exactly. That's one thing wrong with it. You get a gummy bear. I'm only going to make one trip. Carl. Why would you measure something that big in inches? That's a math situation, isn't it? You get a gummy bear.
It says that crown molding is $3 centimeters. Then why does it ask, whatever? Okay, but is crown molding, is it different?
Exactly. You don't know what crown molding is. Right?
Yeah, but isn't there different prices for crown molding? Or is it all like...
Maybe, but the crown molding that I'm going to buy is $3.79 for a linear foot. Do you know what crown molding is?
Yeah, it's like that white stuff that goes around
Around what?
that's the baseboard. It goes...
Yeah, it goes along the ceiling. How many people knew that? But if you didn't, could you do this question? No. That's why it's a bad question. Now let me ask you this. I give you a question on a test that has numbers. You can all deal with numbers. It's a math class. But it's got words that you don't understand. Are you allowed to ask me about it? Yeah, of course you are. This is a math class. I want you guys to be able to do the math. Does everybody understand? If you come across something, and I put this in here on purpose, because I was walking around during the provincial exam that had that question, and a million kids were asking about it because they didn't know what crown molding was. It's a bad question. But it's the perfect, it's the perfect type of question to show you when you should be asking me. Right? Everybody cool? Now, let's explain this. So we know that crown molding goes around the edge of the room. You see up right there, that lighter bit of wood? Pretend the ceiling was right there. We didn't have the big triangle part of the ceiling. That would be crown molding. It goes all along the walls where the wall meets the ceiling. So that's crown molding covered. 2, the inch thing, Carl, that's just there to mess with your head. And 3, a linear foot. A linear measurement is any straight line measurement. So how tall am I? I wish. 5 foot 8 inches tall. That's a straight line measure from my heel to the top of my head, right? Even if I was super stacked Superman weightlifting guy with toothpick legs, because every weightlifting guy has toothpick legs because they never do leg day, right? Nobody does leg day. Only people care about arms and chest. That's it. Nobody does leg day. I love walking by the guys at the gym. They have toothpick legs. Anyway, even if I was super giant Superman guy, like in a V, my height would still be a straight line measurement. Everybody understand? So linear foot means it doesn't matter what the crown molding looks like. For every foot of it you buy, you're paying $3.79. Cool? Try to solve that while I get 3 gummy bears. Yes? First try. They're so much better frozen. Did you do the math yet? What? But I gave you a gummy bear. That's fuel for math.
That's fuel for sugar runs. This fuel for math, okay, then I have some fuel for math. Give me some fuel.
We're going to finish going over this in class. And number 20 and pages 21 to 22 is your homework. Almost all of those pages are one-step conversions. It's not actually a lot of work. So what do I need to do with this guy? What do I got to do with those inch measurements? You got to get feet, right? So what I would do is I'd go 185 plus 240 to get 425. And then I got to multiply that by 2. So I need 850 inches, don't I? But I don't want it inches. What do I need? So what do I do with inches to get the feet? 1 foot over 12 inches. So that's division, right? What does it come out to, Chandler? 70.8. How much crown molding do I have to buy? 71. Because if I only buy 70.8, I'm going to leave a little corner undone. And what's my wife going to say? Exactly. You got to buy 71 feet. What do you got to do with 71? 3.79. Now, just out of curiosity, how many of you, if you were attempting a project like this, would go to Home Depot and buy exactly 71 feet? Why wouldn't you? Because you're going to mess up. You would buy extra just in case, right? Any of you that have lived through any kind of renovation in your house know you bring extra. Or you watch those shows, Flip or Flop or whatever. Nobody brings in exactly what they need. I hate Flip or Flop. Exactly. I also hate Love It or List It. Although my wife's old house was on Love It or List It. The house she grew up in Vancouver, it was on Love It or List It. Yeah. Not when it was hers. She had long since moved away from it. Whoever owns it right now did Love It or List It on it. Try to do number 20 on your own. It's sneaky. And pages 21 and 22 is homework.
Oh, you didn't get cut off by the bell again.
What?
You didn't get cut off by the bell again.
Nope.
You actually finished earlier than
Actually, normally I like to finish way earlier than this. We talked We talked too long, Dave. That's my fault because I forgot that we didn't actually get to that stuff yesterday. The first 15 minutes or so, we shouldn't have even been. You should have had 15 minutes right now to do page 21.
Mr. Myers' garden.
Huh? Oh.